Hey everybody, it's Miss A again. Welcome back from Memorial Day weekend. I don't know about you guys, but this was me all weekend long. And I'm sure that some of us are still extending that long weekend and still grilling and chilling, which is totally fine. I hope you guys are enjoying yourselves and you're getting a lot of fresh air and relaxation. Because, guys, things are coming to an end here. I gotta say, school is out for seniors. Oh my gosh. And for everyone else, this is really one of the last times you're going to hear from me. As far as mini lessons go, seniors, this is our last video together. I hope you enjoy it. I hope it's a good one since you guys are going to be let out early. All my underclassmen, you've got one more video that's going to come to you before the end of the school year that is a mini lesson. So, guys, we are really almost there. We are in the home stretch. And for seniors, I'm going to make this last one a good one. Trust me. All right. So our goal for this video is we're going to be able to just solve simple logarithmic equations and expand and condense logarithmic expressions. Essentially, if you were okay with your rules of exponents, then you should be pretty okay with these guys because it's essentially the same concept. So that might be comforting for some of us to hear. And our piecing guide, I know that it's really hard for us to get back in the swing of things after Memorial Day weekend in school when we're like physically in the building together. So I can only imagine in quarantine where you're in virtual learning, it's got to be even tougher. So if you guys pay attention to these dates here, I'm actually extending this assignment in Delta Math over the course of 2 weeks. Since Memorial Day week, when we come back, is a short one, I figured why not extend it out and you can complete these 3 assignments over the course of 2 weeks. So my little MDW gift to you guys, right? And I'll come back to that when we get through this video in the different parts of it. But before we get started, you might want to pause the video. If you guys can find this table, if you already have it in your possession, if you want to recreate it, or if you just want to go on Google Classroom and pull it up so that it's on your screen or print it out, whatever you guys want to do, now would be a good time to pause the video. This table is going to be super helpful with logs and doing the work that we're going to do. So especially in part 1. So you guys might want to go ahead and grab that. All right, so let's get started. Part 1, okay? For part 1 of this video, I do want to make something clear here. I call this method swoop-de-doop, okay? Nobody else calls this swoop-de-doop. Well, besides Mrs. Rath, but you know that her and I are 2 of a kind here. So if you try and look up swoop-de-doop method or something on YouTube, then unfortunately you're not going to find anything. So just be careful there, but that's what I call it. Anyway, this is a logarithmic equation, okay? And I'm sure that you guys have seen these things floating around before in your other math classes, or maybe on some SAT prep stuff, or maybe the buttons on your calculator, whatever the case might be. But this right here is a logarithmic equation. And all logs are is essentially another way to talk about exponents. Just like how you guys have a different way in your science classes of talking about certain decimals, like numbers that are extremely large or numbers that are extremely small when you use scientific notation, you know, like times 10 to the, and you give it a power to let you know how many times you move the decimal place and in what direction. Logs, essentially, I like to think of them as the same exact thing. They're just another way to express your ideas or a value about exponents, okay? So up here, you're going to see this is logarithmic form. This sentence is read out as log base 3 of 9 is 2. All right, this is a true math fact, and we're going to get to that in just a second. This number down here is called the base. All right, this number over here is considered to be your exponent. And this number over here is considered to be your result, or sometimes there's some books that call it an argument. I just wanted to point that out in case you guys do look up other YouTube videos or anything like that. But otherwise, we've got our base, we've got our exponent, we've got our argument. And the reason that I have these arrows going in this direction is because if you can remember this cyclical pattern here, that is your swoop-de-doop. If you need to know what math fact is being talked about in this problem to maybe solve it when we put some x's in here, or you need to change it to exponential form, if you follow swoop-de-doop, you're going to be able to get this done. So swoop-de-doop. And as you can see, I rewrote it here. 3 to the power of 2 gives you 9. And you guys agree? 3 squared is 9? I think so. So you have now just changed logarithmic form to exponential form, which is awesome. And you can go back and forth, right? So if I were given this math fact and I was going to write out this in log form, what I would do is I would write what you see in black here, log, I would leave a space, and then I would write an equal sign, and I would literally write 3, 2, and then 9, so that I'm writing out my math fact as 3 squared equals 9. All right? Again, following that pattern just kind of helps you to keep track in both forms and to also check your math facts. All right, so why don't you guys just take a second, feel free to hit pause. I have written a math fact in exponential form and in log form. There's a mistake here, all right? Take a look at my math fact, take a look at my log form. If you need to, hit pause. What would be the mistake that I made and how do you fix it? All right, so our math fact is that 5 squared is equal to 25. We all know that that is true. So that would mean if I swoop-de-doop this, log base 2 of 25 is equal to 5 is incorrect, because 2 to the 5th power is not 25. And also, this is not an equivalent statement to this statement that I've made right here. I needed to say 5 squared is 25. So this guy should become a 5. This guy should become a 2. And now I have a correct statement saying 5 squared is 25, or log base 5 of 25 is 2. So there we go. So let's see if we can kick this up a notch and actually fill in these math facts, but also solve for a missing value here using our knowledge. This is where this guy's going to come in handy, because your math facts are going to be right in front of you, which makes things a little faster, a little easier. So let's take a look. Swoop-de-doop. Swoop-de-doop. 5 squared equals x. Because remember, this is our base and this is our exponent. Just like in exponential form, this number is our base and this number is our exponent. It's the same thing in log form. It's still a base, it's still an exponent. So 5 squared equals x. What is x going to equal? 25. If you guys didn't know that off the top of your head, you could obviously use your table. All right, let's try another one. We're going to move the x, all right? Swoop-de-doop. All right, so we've got x to the 9th is equal to 512. Okay, so what number raised to the 9th power is equal to 512? Well, if you have a calculator handy, you can take the 9th root of both sides, because that would cancel, right? 9th root and 9th power would cancel. The 9th root of 512 or you guys can take a look at your tables. And 2 to the 9th power is what's going to give you 512. So 2 to the 9th is going to be equal 512, so x is equal to 2. Last one, we're going to change where the x is again. Again, swoop-de-doop. 3 to the power of x is equal to 729. All right, so 3 to what power is equal to 729? And if you take a look, either on your table or you do trial and error, 3 to the 6th power is going to give you 729. Just want to show you guys that last one here. 3 to the 6th power, 729, just in case you forgot how to use that table. All right, and that's all you're doing for part 1. So since this concludes part 1, if you guys are ready to go, Tuesday right after Memorial Day, you guys can go ahead into Delta Math and complete the problems in logarithmic form. All right, part 2. In part 2 and in part 3, we are going to be taking a look at properties of logs. So if you guys need to hit pause so that you can copy this down or color code it or whatever the case might be, you can go ahead and do so. My students, I know that you have been keeping your vocab notebook, so this is actually in your vocab notebook. So if you just want to take a look at that and use that as your notes, that's totally fine, whatever you guys want to do. But essentially, we have 3 properties that we're going to be using, and we're going to be able to expand and condense these 3 properties. So what do I mean by that? The product property has to do with, product just is a fancy word for multiplication, right? And when you have log with a base of 2 values being multiplied, they could be numbers, they could be variables, they could be a mix of those things. You can expand this to be log base b of u plus log base b of v. This is kind of similar to your rules of exponents. When you multiply like bases, what do you do with your exponents? You add them. Well, when you are multiplying logs of the same base, you can add them. The rule still applies. Quotient property. Quotient is just a fancy word for division. When you divide like bases, you subtract your exponents, right? So again, if I have log base b of u over v, numerator comes first, log base b of u, minus denominator comes second, log base b of v. We've also got our property, power property. And what that is saying is that anytime you have an exponent to a base, then what you are going to do is that exponent is going to become a coefficient. So instead of log base b of u to the n, you would expand that to be n times log base b of u. If you need to, guys, go ahead and put a little multiplication symbol right in between so that you don't forget that. But essentially, everything that you see here on the left-hand side is the condensed version. Everything you see here on the right-hand side is the expanded version. And that's obvious because the left-hand side looks more condensed, it's smaller, has less terms. You only have 1 term as opposed to the right-hand side where you have 2 terms. Biggest mistake that I see here is that students will put log base b of u over log base b of v. No, it's log base b of the entire fraction. So again, over here, guys, if you need to put parentheses, go ahead and do that. It's log base b of the entire fraction, okay? And then also, just another helpful math fact is that logs are going to be naturally based 10. So if you see an expression where the base is missing, then that's okay. Like I wrote here, log of x, it is actually base 10. That's just the base that it's like programmed in your calculators for, so on and so forth. But you can change that base at any time. That's coming later. But if you don't write it, then it is okay to assume it is a 10. Just kind of like when we don't have an exponent, we know that it's a 1. When we don't have a coefficient, we know that it's a 1, right? Same thing here. When we don't have a base here, we know that it's a 10. All right, so let's go ahead and use these properties. So in part 2, we are going to be condensing. So write the expression below in its simplest form as a single logarithm. So this guy, you might be confused and say, well, he already is a single logarithm. There are no other ones. But remember, coefficients, where did they come from? Well, they were once exponents. So we're going to rewrite this as log base b of 2 to the 5th But remember, guys, these are simple math facts. 2 to the 5th, we know. We have a table that we can look at. We have calculators that we can use. So you want to make sure that you clean this up a bit. And we say log base b of 32 as our final answer. Okay, so make sure you guys are simplifying as much as you possibly can. Number 2 is a little bit more complicated. I'm seeing addition. Remember, addition and multiplication are the properties that go together. So this addition is going to turn into this guy right here, this 7 and this 5 being multiplied together. So I'm making this one single log. So log base b of 7 times 5. Right? 7 times 5 is going to give me 35. So I should clean that up. Log base b of 35. And we're done. Our next example, we've got a little bit more going on. First of all, I'm seeing subtraction, so that means I'm going to turn this into a division problem. I'm also seeing a coefficient, so that means that he's going to turn into an exponent. So remember, this one's the tricky one. It's log base b, because again, they're using base b's. If Delta Math or the problem that you're working on is using base 10 or base 7 or base 5, whatever the case might be, make sure that you're using that. But we're going to have our numerator coming first. So this is going to be 3 to the 3rd, right? And then we're going to have our denominator second, log base b of 3. I'm just going to clean that up first so we can see it. So this is our numerator. This is our denominator. So we've got log base b of 3 to the 3rd over 3. And there's 2 ways that you can go about this. You can use rules of exponents. There's 3 up here. There's 1 down here. There's 2 left in the top. So we've got 3 squared. You can carry this out and make this a 27. Whatever the case is, if you want to just do 27 divided by 3 and get your 9, that's going to turn this into log base b of 9, final answer. All right, last one. Again, a little bit more going on here. This 3 is going to turn into an exponent. So I've got log base b of 2 to the 3rd plus log base b of 7. This guy 2 to the 3rd, you can change him to 8 right now. You can change him to 8 later, whatever the case might be. Remember that this is going to turn into a multiplication problem. So I'm just going to rewrite it. Log base b of 8 plus log base b of 7. We're going to multiply since we're adding here. So it's going to be log base b of 8 times 7. And 8 times 7 gives you 56. So log base b of 56. And we're done. And that is all for condensing logs. I do want to point out to you guys that in Delta Math, just so that you're not confused, how they write out the answer is they already write log base b, so you don't have to worry about that. You just want to write what your final answer is in here. If you need any exponents for any reason, you can click on this, this little keyboard right here, and it does have an exponent button if you needed that, just so that you guys aren't confused. All right, and that concludes part 2 of our video. So if you guys are good on Friday, take a few days. There's 3 days each for each of these. But on Friday, you guys can start condensing numerical logarithms. All right, last bit, part 3. All right, so we are going to apply those rules again, but this time we are going to expand our logs. So I am seeing multiplication that is going to turn into addition. So we can rewrite that as, I'm going to go over here, log of 4 plus log of x squared. You might notice that there is no base written. So what is the base? 10. Very good. You don't have to write it. So we've got one more thing that we have to clean up here. We can't leave exponents in an expanded form. We have to turn them into coefficients. So if we do that, it will be log of 4 plus 2 times the log of x. And that is our final answer. All right, try another one. We've got division. This is going to turn into subtraction. Remember, it's numerator minus denominator. So let's write this out. We've got log of x to the 5th minus log of y. Again, this is a log base 10 problem. I don't have to write that. And remember, we can't leave exponents in a final answer for expanded form, so we're going to make it a coefficient. So 5 times the log of x minus the log of y, final answer. Number 3, again, we have a multiplication situation going on here. This squared is only belonging to the x, so make sure that when you divide it up, you've got log of x squared plus the log of y. All right, and then again, this guy's going to come out front and he's going to be our coefficient, so 2 times the log of x plus the log of y. Final answer. And the last one, a little bit messier. We've got an exponent for everyone, but remember, division turns into subtraction, numerator minus denominator. So we've got log of x to the third minus log of y to the fifth, and both of these exponents need to come out front as a coefficient. So we've got 3 log of x minus 5 log of y. And we're done. So that concludes part 3 of this video. So on Wednesday, June 3rd, if you guys are ready to go, expanding logarithms level 1 is what you guys are going to work on. For my students, I will have quizzes available for some enrichment and a review quizzes at the end. But for my seniors, since this is our last time together, just wanted to give everybody a big old air hug. I'm going to miss you guys. I hope that you are, going to miss my little videos and everything. But I have a little song to play for you guys here. So excited and we get so scared, laughing at ourselves, thinking life's not fair. And this is how it feels. As we go on, we remember all the times we had together. And as our lives change, from whatever, we will still be friends forever. For those of you who don't know, that was the graduation song from Vitamin C back in 2000. It was a big old hit on graduation day. I hope that you guys enjoy your virtual graduation. I'm so proud of you guys. I'm actually getting a little teary-eyed thinking about how I know that this is a really big moment for you. And, make it your own, make it special. My husband graduated with his second master's, and his graduation ceremony was canceled as well. And I know it might sound silly because it's his second master's, so it would be his third graduation walking in for a college diploma. But, it meant a lot to us and our little family that he did what he did, and we created an at-home graduation, and it was hilarious, and we had family on video chat, and it was so much fun, and everyone had such a good laugh. Make it your own, guys. Be proud of yourselves. I'll miss all of you. I'm not going anywhere, so come on back to SHS and find me. Congrats, guys.